This complex inequality breaks into two parts, like this. We'll say on the left-hand side, it's 9 is greater than 3x plus 12. And on the right, we'll say that 3x plus 12 is greater than negative 9. Oops, daisy. Negative 9. Okay. And so then on the left, let's solve for x. And then the first step will be to subtract 12 from both sides. These 12s will cancel. And so you get negative 3 is greater than 3x. We'll divide both sides by 3. And so you get negative 1 is greater than x. And we'll plot that over on the number line. X is less than negative 1. Let's say this is negative 1. Open circle, going to the left. Okay. Now in blue, 3x plus 12 is greater than negative 9. We'll subtract 12 from both sides. And so we get a larger negative number. That's going to be negative 21. So we get 3x plus 12 is greater than negative 21. Oops, sorry about that. We'll just have, rather, 3x is greater than negative 21. Divide both sides by 3, and you get x is greater than negative 7. Let's plot that on the number line. X is greater than negative 7. If we come over here, let's say that this is negative 2, this is negative 3, negative 4, negative 5, negative 6, negative 7. We'll say x is open circle greater than negative 7. And so the solutions to the inequality it happens from here to here. It's where they both overlap, because it's a double inequality, so the word and is implied here. And so we have to have both inequalities being true in order for there to be a solution. So a good solution for this inequality would be, for example, negative 6.9. That would work. Or we could have negative 2 or something of that nature. All of those would be possible solutions to this inequality.